All right. Let me mute. Can people confirm that you can hear me loud and clear? All right. Thanks, Ben, for confirming. Welcome to kind of a last-minute live stream. I've actually been thinking about doing this for, I don't know, 4 or 5 months, but just haven't had the time. And currently, I have the day off because NVIDIA gives us company days, and I didn't have much going on today. So we are going to do this live stream of coding, something to do with combinatory logic and combinators. This isn't my composition intuition talk. That's going to happen in June. And Bryce is actually potentially going to join in like 5 or 10 minutes, and then we might take a digression because I'm not sure if he saw the link for this, but he messaged me an hour ago and was like, I need your help with combinatory logic stuff. So we might have a guest appearance. Stay tuned for that. Before we get to that, though, it says I'm very quiet. Is that better? Actually, let me check this. Is this better? Testing, 1, 2, 3. Let me know if this is a lot louder. All right, a couple yeses. And also, feel free in the chat, ask any questions if you want. Let people know where you're tuning in from. And yeah, it's a good way to get some conversation started in the chat. Before we start talking about combinatory logic, I'm just going to plug all this stuff. I have been trying to release more YouTube videos recently, but in 2022, there was like an 8-month period where I didn't actually release too many videos sort of the, X programming languages and one programming problem. But I have been very active on all this other stuff. So I have a podcast with Bryce Lelbach. We just released episode 119 just this morning. Check that out if you want. It's all about algorithms, data structures, etc. I have another podcast on array languages. We release an episode every 2 weeks. So if you're interested in programming languages like APL, J, K, Q, etc., check that podcast out. I just started a running podcast. Probably most of the subscribers or viewers on this channel don't care about that. But if you do, check that out as well. I'm about to drop all the links in the chat. I was asked to shout this out, and I probably will do that in a dedicated APL video later on. But there's going to be a free half-day conference later this month, I believe, because we are in March now. So yeah, this is Wednesday, March 22nd. Completely free half-day conference. If you're interested in array languages, there's a bunch of talks that are going to talk about sort of how to get started and why you might care about the array languages. Check that out. On top of that, if you care about other stuff that I work on, I basically have a repo on my GitHub called Content, which keeps track of every single talk that I'm ever giving, including future talks. So right now I have 3 confirmed talks at conferences in 2023. I've submitted 2 others, and they may or may not get accepted. And if you happen to be in any of these places, New York, Poland, Italy, the UK, or Toronto, I think Italy is a free conference. The other ones you have to pay for. But if you're interested in going to those, feel free to check those out. And I also have other stuff, appearances on other podcasts. And I think that's all the plugs I have. So before Bryce shows up, what are we going to be doing today? Combinatory logic. I have this website. Oh, actually, wait, and all the links. Let me copy and paste. So everything that I just mentioned, including this combinatory logic website, except this is over the allowed limit. So if I type that, and then I also go get the last 2, those should be all the links, except I don't even think that worked. All right, let's do these links one by one. There's the first one. There's the second one. There's the third one. There's the fourth one, fifth one, and last but not least, the sixth one, because clearly YouTube chat did not like me posting multiple links at the same time. So we're at the last one right now. This is combinatorylogic.com, and this is basically a table that details combinators, which in my opinion are basically ways of composing functions. So if you're familiar with Haskell, the dot operator is the B combinator. It gives you the ability to compose two unary functions together, where basically A here is your first unary function, B is your second unary function, and then C ultimately will be your argument. And the purpose of this video is going to be to code up a C++ program that converts basically this combinator form that spells a combinator in terms of other combinators into its lambda or function abstraction form. Because I think that like defining, so this CR here, if we go to links and we go to the next page here, here's a bunch of tables or links that you can find across the internet. And if we go to the first one by Chris Rathman, this for the longest time was basically my go-to source for combinatory logic stuff. And is there a lag? There probably is a lag by a couple seconds, but it shouldn't be too bad. All right, so we're going to pause this explanation. Let's copy this. Open Microsoft Teams. All right, here we go, folks. I'm going to need to put my headphones on for this. And except that I don't think Bryce. Are you there, Bryce? All right. Wait. Now the question is, can folks hear Bryce? I don't think the answer to that question is yes. People can hear Bryce? Negative. Nope. Well, people can see your headshot now. Let's see if I can turn. Look at that. If you go to my YouTube channel, you will see your face is live streamed. Although people can't hear you, so we got to sort this out first. Desktop audio, audio input capture. Oh wait, can people hear now? Oh no, that's just my. The scientist Andrew Garfield. So people still can't hear Bryce, correct? All right, here we go. I think. Say something now. So let's get rid of this. I guess we should have tested this before we went live. I just need to keep switching these until people can. Speakers. Say something now. Say something now.
Hello.
Hey, there we go. All right, let me confirm that this works. I think so. Yeah, I just switched in OBS. Yeah, we can hear him. All right, we're good to go. You're now live in front of roughly 100 people. What are we?
There's 100 people that want to listen to you on a Friday.
Apparently. We'll
Are you
see.
going to turn your camera on, or is this just
Well,
going to be
so
lonely?
I'm sharing my webcam capture with OBS, so I can't share it with you as well.
Oh,
But if you go
okay.
to the YouTube channel, people can see my face. Your face is much larger than mine.
Sounds like you really want me to go to your YouTube channel.
I mean, you're already a subscriber, right? I assume. For folks that aren't clear, I plugged ADSP, the podcast. That was the first thing I plugged. This is Bryce, my co-host. We both work at NVIDIA.
Your
And
co-host and dearest and closest friend.
I got I got podcasts with other friends now too. So it's a contest. Which of my
That's
good
true.
friends that are also co-hosts with me on podcasts.
Oh, I just went to YouTube. It says that 39 people are watching, not 100.
Oh yeah. Sorry, I was looking at viewers. No, so there's
Yeah,
concurrent viewers. Currently, it's at 44. Overall views is at 101. So they might have dropped off as soon as you joined. That's probably what happened.
probably.
What are we doing? So you messaged me like an hour ago saying you needed help with some combinatory logic stuff.
Well, what I really need you to do for me is, um, if you were to design the C++ standard algorithms from scratch with no um, with no consideration for existing history, like what would it look like? Um, this is in the context of I'm looking into building a prototype of an async algorithms library. Um, and when I was doing that, I came across a few things where I wanted that S combinator pattern. Um, when you have these pipeable algorithms in C++, like you do with ranges, and you do with async algorithms, there's always the question of what should you return. Um, Even like ranges has this where some of the new range-based algorithms, they do this like weird thing where they return this thing that has both the input and the output. Have you seen that?
Both the input and the output? What's an example?
Yeah. Hang on. Let me go. Uh, what's an algorithm? Partition. Hang on. I'm amused that I, the chair of the C++ library evolution design group, just had to spend about 5 seconds thinking of just the name of any algorithm. Didn't matter what algorithm, just any algorithm.
Well, you got roasted pretty hard by Zach on today's episode, part 3 of our 5-part series with him, where he was giving you a hard time for not knowing the name of adjacent difference.
Yeah.
To which you replied, I wrote the wording for it. Is this a
Why
ranges
can't I
algorithm,
find
or
it?
is this a C++?
Yeah, like this is the ranges in out result stuff.
In, out.
If I share my screen, can people see it?
Yeah. Do you want to share your screen? I can take you off of.
So
You gotta zoom in a tiny bit.
this
Zoom in a tiny bit
this stuff.
for the viewer.
Oh yeah, zoom in. These things. You familiar with these things?
These are if I remember correctly, in the C++20 range versions, range overloads of the C++98 and 11 algorithms. They came up with the design decision to, instead of returning pairs, return name structs where the members of the structs have specific names. So, for instance, stood mismatch from C++98 just returns you a pair of iterators, but stood : ranges : mismatch returns you a struct that's called result something, and the members, so mismatch returns you a pair of iterators. If you had to guess what the name of the member variables of that result struct would be, what would you guess? Like first, second, something like that? No, it's in1 and in2.
Yeah.
And I didn't know about this stuff until C++20 had been standardized. So say what you will about the design decision of it. There are certain algorithms in the C++ ranges namespace in C++20 that return these named structs with named variables. That's my
Yeah,
understanding of this stuff.
so I don't know, no clue why this was done, but uh, this is something that comes up when you think about like what do you want your pipeable algorithms uh, to give you. Um, and there's an argument to be made, I think, that maybe you want your pipeable algorithms to do this, to send to the next thing in the chain. Just like all the things, because you don't want to lose context. Like maybe a pipeable reduce should return the range that it reduced over and the result. Um, but I think that's all nonsense, because that just gets very ugly very quickly. But then for another thing, I had to write something that was quite similar to the S Combinator, which was an adapter that it extracted the asynchronous context from the stream, and then it called a function with the asynchronous context from the stream um, uh, and um, uh, and then sent along the results of that function. But that was pretty easy for me to do. And then after I did that, I was working on adding some algorithms like reduce and transform, partition, some other things. And it just occurred to me, well, if I just had the S Combinator, then things would be a whole lot simpler. And so I thought it was the S Combinator, and then I tweeted at you, and you said yes, it was, and I was like, aha. So now I think I just want that.
I mean, yes. So I mean, I'm not sure if we should share with the viewers the example that you
What do you
showed
call
me.
it?
It is the S Combinator. So what you showed me, if you is it safe to bring up our tweet DMs? I see one of the tabs there.
Almost certainly not, but well, here, let me get
Also, I
some another
apologize
window.
for the construction. Hopefully the jackhammer doesn't start, which was going on 30 minutes ago while I was talking to my sister. Happy birthday to my middle sister, the one in Dublin. It's her birthday today.
Oh, wait 1 second. I need to put this into a window that I can actually show people. It doesn't have like excessive NVIDIA things. Hang on. I'm working on it. So the problem is, if I do that, well, no, this will be fine. All right, so I asked you, if that I want X Fy that produces the tuple of Y of X Y this. This
Yeah.
is the S Combinator.
Yeah, that's the S Combinator. Where
And so where this gets useful is if I'm doing something. So in C++, the syntax for like piping things is let's do okay, this, boom, right? Makes sense.
mm-hmm.
And so then
What
what
is
if
S here? Did you just choose a bad variable name for your
well, it
Yeah,
was meant
okay.
to be a sender. Let's
Gotcha.
call it a See, now you made me spell out so many more things, so forget that. But maybe I want to do something like normalizing a vector, right? Where I want to I'm going to do something with the range later. Maybe normalizing a vector is a bad example. So let's just start off with this example. So we could do, give me a name for this S combinator.
S. That's what it's called.
Give
S.
me a more descriptive name.
I mean, in Haskell, it's also known as AP, which is short for applicative, which is like a category theory thing, but that means less to me than S does. Oh yeah, Starling. That's a good point. Dunya Kirkali, if I'm pronouncing that name correctly, in the chat just said, give it the bird name. So this is the Starling bird. So call it Starling. There you go.
How do I spell this?
Starling. There you go. There is actually a Haskell library called data.aviary.birds where the S combinator does have this name. So there's precedence, Bryce.
In this case, I think we would just do this, and that would give me what I would want. So now I've got...
Starling takes two functions. It takes a binary function and a unary function.
Is it going to be clearer for people if I do this? Why does it take two functions?
Well, so the composition pattern, if you look at
I want this.
The top, is that your two arguments to F. I mean, technically I would type the S combinator slightly differently because there's like an implicit binary function in your x comma y paren x paren, which is make tuple. So really what you should type is type F parentheses a comma b x. This would be easier if I could type it.
What?
Go to your F.
Yes.
And then type paren a comma.
What? Where? Here?
In front of the paren.
Yeah.
So you already have a paren. Delete the x comma space y.
Just tell me what to type on a new line. You're not making any sense.
Okay. F left paren a comma space b comma space x.
Okay.
And then an arrow.
And then you want...
And then really what you want is a paren x comma b paren x n paren n paren. And the implicit, so this is the same thing. It looks different than what you have on the first line, but implicitly a is a binary function and it's implicitly make tuple or make pair on your first line. So you have like an invisible binary function that is forming a tuple, a two tuple or a pair, whereas the S combinator has that explicit. So in order to do what you want, you would assign A to be make pair or make a two tuple. B would be some unary function, transformation of some sort, and then X is going to be your argument at the end of the day. So
there is the interesting question with senders. Senders can potentially send multiple things. So if you, then maybe it'll be clearer to. Okay, so this one, I want it to be sender of like range T. Okay, hopefully I haven't killed anyone, confused anyone yet. Okay. But there's also, you could have, let's just call it for now. Let's say it sends two things. Type. So, and in this case here, do you should this be like this, or should it be like a tuple?
I mean, I'm not even sure I understand Q yet, because Starling is still missing.
I don't care. I don't need this thing. Like, I just want this thing.
I mean, you can't.
I don't need this extra.
But like, you have to explicitly pass it. As soon as you're hard coding a binary operation into one of your combinators, you now have something that's like super specialized and doesn't have a name. So like,
that's fine.
That's fine. All right. Well, so for the viewer, what Bryce wants is an S combinator where the binary function A is hard coded to make pair, and that's how you would describe that in combinatory logic terms. But call that whatever you want. And so don't call it Starling. Let's just call it Bryce's.
I'm going to call it with.
Okay, call it with. And reduce is your unary function, and then that's going to apply. So you're going to end up with a tuple of whatever is calculated from transform, and then also transform with a reduction plot after it. All right, so that's what Q does. And now U is passing range to Z, and then Z sends two things of type X and Y. So how does it send that? In a tuple or a pair or something like that?
No, the way that senders work, you can just send it as like a variadic pack. So it's not sent through anything in particular.
Okay, but there's multiple things. Well, then it doesn't really change anything as long as your unary operation knows how to deal with that unspecified group of things.
Yeah, but so should you end up with
you would end up with a pair or a two tuple of your variadic pack of things, and
well, no. You could end up with that, or you could end up with this. The first one here.
What do you mean you could?
Like, you could do that. You could have this with thing send the variadic pack from the first thing, and then whatever you get, and then just append it to the end. I guess you could actually also end up with this. But that seems...
So you're saying you could end up with this, meaning that just depending on how you defined your custom thing with, operation, it could do a bunch of different stuff? Okay. So then what's the question? What do you call this? Or
no, the question is what should it send? Should it wrap it in a tuple? Or should it just do the variadic thing? I think it shouldn't wrap it in a tuple because the common case
that would technically be a different combinator. That would be the phi combinator. That would mean your implicit, like you have a specialized S combinator where you're just passing along the initial argument, but by adding on line 16 a tuple to it, that's technically another unary operation. If you consider your list of variadic things a single entity, make tuple on that list of variadic things is a unary operation. So now you have two unary operations: your reduction, you're forming a tuple from a variadic pack, and the implicit make tuple around the whole thing, or make sender, whatever it is. So it's definitely not 16.
I figured out in this context what the
It should be 14 is my take. Based on my understanding.
I mean, I think that's the only reasonable outcome. So the most common thing that you're going to do with this is you're going to, I'm not sure why I'm calling this that. I'm just going to call this F, so I can call the next one G. Okay.
And also, too, while you're typing all this stuff, like I would argue that you don't even really need width. Like if we get the pipeline operator,
I'm getting there. I'm getting there.
With the placeholder,
so
you can just.
So if you have this, this is the F combinator. The combination of those two.
You're just making this up so that F is some custom thing you just defined?
No. Sorry, I meant S combinator.
I mean, we've already established that it's not really the S combinator, but.
No, it is. But you're not reading what I'm writing here. What does this do? This does G of. Let's call this one X. This does G of, and let's call this one F. This does G of X of F of X.
Okay, I understand.
I don't know whether I want to give it a name. I'm not inclined to give it a name because this seems like it's an unnecessarily like separation of concerns.
Well, so here, type something out for me. Go to line 23.
Yeah.
And go auto space U equals X pizza operator. Give me a little pizza sign. What?
Yeah.
That's the opposite direction. I want the pizza the other direction. And then go G, paren, underbar, comma, F, underbar. Yeah. Like, why not just do this? Why do you have to name everything? With and then seems like more complicated than just having a sophisticated. Although, according to Zach, when we talked to him on ADSP, he said that Barry has a new proposal. But like, this is my argument for like what C++ should get, because
you're right. I could do this.
Why do we need to like name all this stuff when we can just basically implicitly build up these composition patterns with a pipeline operator and a placeholder? Like, I think this is the most, not elegant solution, but like the best solution for C++ as it like stands today, because we don't require the programmer, the developer, to then go learn like a whole vocabulary of like with and then, or S and B and B1 and K and such stuff like that.
Well, I mean, sure, if we have that. I don't have the problem is that today I can't make that, because G and F are both user code. They're just user functions.
That's fine.
I mean,
today we can't do that, but if we get get some moral equivalent of the pipeline operator, like that will be possible in C++ 26 if it gets shipped.
Yeah.
Which is like the dream. And like, this is, in my opinion, it's actually like better than what you can do with like Rust traits, because you can't do this like passing multiple things twice, or passing the same thing more than once with like Rust traits. You can't do that, at least to my understanding. I have not been able to figure out how, which is exactly what Barry Revson said when I asked him about that.
Let me write norm. And I say that because it's a litmus test that I often use. Let's see.
So yeah, this is implicitly the phi combinator if you build it up, but really you want division first. You want division Paren.
You let me build it my way first, then you can tell me how you want to build it. I actually want.
Medhad is asking, is the pipeline just another way to write a lambda function? It's one way. It's one way to look at it. It's not really, but Barry did mention that in a few episodes ago on ADSP that with the pizza operator, you kind of do get a new way to write lambdas.
Now I've got it giving me x and then the reduction, and then
someone in the chat says that Fabi Caruana, who I think is a chess player who has a similar hairdo to you. We got to let Bryce think though. He's deep in thought here.
Well, then the other problem that I have with this whole senders thing is that it lets you send. There's no good way to actually muck around with like you can receive multiple values, but there's no good way for you to easily send multiple values.
Well, so I know what you're trying to do, and I know how to do it. You have not been.
Yeah.
All right, so go to line 26. We'll leave your uncompleted thing. So go auto space norm equals x pipe.
Yeah.
And then go div paren. And then go underbar.
Yeah.
Space or comma space. And then technically, if you have rank polymorphism, you can just go, what are you normalizing by? The maximum?
Yeah.
Yeah, so do max, paren, underbar, and paren. So if you have rank polymorphism, where the scalar that's returned to you by max will be, like div will be able to figure out that you have a sequence, you have a rank 1 thing for your first argument, and a rank 0 thing, and scalar for the second. If you don't have rank polymorphism, you have to wrap the max inside a repeat, which would still work just as fine. And if it's lazy, you don't even need to specify for how long. It'll just match the sequence length of your first rank 1 sequence. But this is an example of technically it's also the S combinator. A binary function with a unary function, div and max. But once again, the user doesn't need to know that. We show people enough examples using the pipeline, or technically you're missing it's supposed to be a pizza operator, the pizza operator in these underbars, and people are just going to figure out, oh, however many times I want to pass things, I just use parentheses. Like I said, it's not the world's most elegant thing, but I think for C++ developers, this is something that like is pretty easy to teach and not that hard. You don't have to learn a whole new vocabulary for educating the C++ folks at large.
So div here is I really want to write this in terms of like a transform. That is an operation that takes the division true.
That would be a more C++ way to do it.
Yeah.
So you would just rename div to transform and then pass stood : divide as the third argument to this, and it'll work just as fine, right? So go comma and then stood : divide, paren, brace, something like that. Yeah, this is much more C++y.
Well, and then the other thing you can do, and this is why
and in this case, because we're being more C++, like you would want to wrap the max inside a repeat, because our overloaded transform can't deal with a sequence as its first range and a value as its second range. It needs to be 2 sequences or 2 ranges.
Yeah, and I think my one concern with that, I would never want to write it this way for parallel operations, because it becomes very unclear what order things happen in. Like, it's very implicit here that the max element happens before the transform.
I mean, admittedly, you do have to calculate the maximum before you can do the transformation, right?
Yeah, but I'm just saying that I prefer to have it be
Just
clear in the
have
pipeline.
it calculated out front.
Yeah.
Yeah, that's fine.
Problem is, how do I? Yeah, this gets unpleasant because you got to do. Then you got to do the repeat in there. Right, you need to return. Yeah, this is admittedly more terrible.
And I think the other thing you have to consider too is like this with then pattern. Like,
yeah,
how do you restrict people to, it's much harder, it's much easier to like misuse this in that with creates a tuple of like multiple sequences, and then the then is going to apply some unary operation to the second sequence in your two tuple. But
wait, what? Whoa. Well, let's go back to your first statement.
So
I don't
like,
think.
oh, so actually, yeah. Why? What is the with reduce? Why? Actually, I'm confused now. I thought you were doing something else. What is? Because there should be no reduce with. I think the repeat max should be your reduction, right? Or your repeat max should replace your reduce.
With reduce is gonna do the reduction with, like, I've just left out the placeholder because we don't have the placeholder syntax.
But what's the
reduction? It's gonna take x. This is gonna send it's gonna send x comma reduce x. And then this is going to send.
Are you trying to? This is the same norm example though, right? So in this case,
yes.
your reduction is not a reduction; it's max repeat. It's repeat max.
Sorry. Yes,
And then
sure.
If we're following what your example on lines 18 to 21 does, then is only responsible for sending, or like for passing along a binary operation, which in this case is your transform divides. So like with takes care of your repeat max, then takes care of your transform divide.
No, then is all that then is doing is turning the second argument into a range 2 so that I can do transform divides. It's divide or divides. I forget how we spell it in C++.
Divides with an S, I believe. Actually, no, without an S. Actually, I could be wrong. Someone in the chat can Google it for us. This is not. What? Someone just said in the chat, my son got bit by a bird, and now I can't compile hello world. I don't know what that means. I'm sorry that your son got bit by a bird.
But this is like a weird transform because it's like an in-place transform, but also one that takes multiple things.
So wait, let me see if I understand this. So with is a higher order function that takes a composition of two unary functions and composes a composition pattern. You then pipe that to then. Which has repeat max again after you've already done reduce max. I don't know what the reduce is.
The reduce is just like std reduce.
Oh. So max now is a binary operation that is passed to reduce to form a reduction.
Yeah,
okay,
sorry.
That's different than what we had
confusing.
above. We were assuming max was the entire reduction.
And then this is a um,
So like this is
a binary
I think
transform.
I understand what this is doing, but this is inconsistent with what you have on 18 to 21. Technically,
How so?
I guess actually it's not.
Zip transform's not pipeable, right?
No. Which is why we need the
Well, this is
why we need the pizza operator, because um I mean, so, but like, I just, yeah, I mean, you can write it this way, but you're basically the binary function g that you're passing to then on line 31 is just basically a make pair, which is just like, why not just call the transform divide there? Is why I guess I'm
Huh?
like, what is your
Then is not call is just called a single time. But well, okay, but the other problem is that uh, don't actually want that done that way, because that's going to run it. That's a scalar function. Don't actually want it done that way. And that's why this is why I have the form of reduce that sends the function. That's why I have the form of these algorithms that sends the function to. This then is a scalar function. It's not element wise. It's scalar. That's what's confusing you. But this is not actually how I want to write the code.
I mean, if it's scalar, why do you have a repeat in there?
Hang on, I know how I want. Wait, what? Say that again.
Like, I don't entirely understand what you mean by
This
scalar.
that repeat is a view. Repeat is a view. This is returning a view. This does nothing. This does no work.
Mm-hmm.
This does the reduction, but then you have a range and a scalar, and we don't have rank polymorphism in our in our algorithms.
Yeah, okay, I see what you mean. I mean, I guess this works. I just don't know why you'd write it in this many steps.
I think what I actually want to do is I don't want to do it this way. I want to send or actually what I really want to do is I want to send like a bound divide. Yeah. But this still creates the same problem for me, doesn't it? That you've got this scalar function in between the two parallel functions.
What's your problem?
That you've got this scalar function that needs to run between these two parallel functions.
What do you mean by scalar?
Then you have this function then, which is a scalar operation. Like this is a single-threaded operation that does no meaningful work. It just needs to exist to hook up the interface, like to hook up between these two functions. And it's a scalar bubble in between these two parallel operations.
And what is your end goal?
To not have that. Because it's...
I mean, how do you definitely have to do the reduction first. That's
I'm not, you're not, this thing in the middle, there's 3 steps here. There's
yeah.
a parallel reduction, there's a serial this thing or this thing, and then there's a parallel transform.
I guess, yeah, I'm lost on why there's a problem because you're just creating like a unary function. Like, why does it like, how could that be parallelized? Yeah, I'm confused.
You don't want it to be parallelized. I don't want it to have to exist. Like, you still have to run it somewhere. That's annoying.
You don't want it to exist.
Yes. I don't think I can get around it, though.
I mean,
like, it's another kernel launch that you have to do on the GPU. I mean, I guess you could fuse it into the reduction kernel. You can probably do that. That's probably fine. But if you don't do that, it's, well, that's actually a lot harder to do generally, especially if it's like user code there.
I mean, it's unclear to me why. Is this necessary purely because you need to find a way to like do the implicit repeat thing with your lambda here? Or like, why is there not like a version of transform?
Because this, it's not about this particular problem. It's about the general problem of people want to compose together different algorithmic operations, and sometimes there's little pieces of work that has to be done in between them, or there's little, there's little interface problems like this that need to be solved. This is a case study. This isn't about this particular example. Solving this particular example doesn't solve the general class of problems.
Your issue here, though, is that you have a scalar from the reduction and your original sequence that you're passing along ultimately to some transform function, whatever. The details of what reduction and what operation afterwards, it's just that the APIs don't match. Your final operation.
It's more about that there's an operator to a future function that is dependent upon the result of the earlier function. That transform takes 2 inputs.
Mm-hmm.
It takes sequences and it takes a transformation function.
Mm-hmm.
Both of those can be asynchronous inputs. It's not sufficient to only support to only allow people to well, that's really the question. Is it sufficient to allow people only to do to only send the inputs, so the sequences, or do you need to allow people to send the operations too? And you see what I'm saying?
I did not understand that last part. I could see the difference in the code, but
well, let's
you're saying
just think about the reduction. The reduction takes a range and a function, right?
Mm-hmm.
This is like and returns you a t. That's the synchronous version. Okay, the asynchronous version. This is what most people think the asynchronous version needs to be.
Mm-hmm.
Because the input needs to be asynchronous. The question is, though, does this need to be asynchronous? Do you need to be able to send the function as well? And it's the same question for transform.
I don't understand. Well, what is the difference between a sender function, a function that's going to
It's a difference. It's the difference between do you need to be able to, is this an asynchronous, is this something that you're going to know when you launch it what the operation is going to be? Or is the operation, is it important to be able to have the operation be something that is asynchronously provided by the previous thing in the chain?
I mean, you can't do any work without it, right? So
Uh,
if you
the
don't know what,
question is, do you need to, is it important to be able to pipe the operation into the transform or the reduction?
to pipe,
Right. In this second example here, we are sending the operation, like there's no function provided to this transform. It gets the operation from the previous thing that sends it. Is that an important capability?
I don't see why you would want that. In fact, it seems like you're like the binary operation, at least for this example transform, like maybe there's another one where it makes more sense. Like it is customizing the behavior of your transform to require that from the previous thing that is being piped into transform seems like unnecessary coupling. Like not only unnecessary, but like
I'm not saying require it. I'm saying that that you have you need to have the option to do that.
Is there like a motivating example where that is something that you want to be able to do?
This sort of thing is the motivating example.
I am not motivated by this example. I think that the first line 29 to 34 is like much more what I would want to write.
So your answer then is that if you need a scalar in your transformation function, you should do this.
That or use a rank polymorphic library. Yes.
Or maybe transform should be rank polymorphic.
Yeah.
Maybe transform should do this
Or
implicitly.
add a set of rank polymorphic overloads to your algorithm library. That's more than possible as well.
So you could just
ignore the repeat, basically. In fact, I'm not even sure if then is needed. Yeah.
Right.
Yeah, I mean, this is, in my opinion, and also this is something that I haven't talked about a lot, but my evolving view is that rank polymorphism, like it's not a coincidence that array languages are the best paradigm for programming with combinators, because you're doing a lot of this stuff that, like in your words, kind of results in API mismatches. But when you add rank polymorphism into the mix, the ability to use operations on differently ranked arrays, you end up with way less of those API matches. And it's much nicer. And you don't really realize it when you're in APL or J or BQN. You realize it when you go to Haskell and you try and do something, and then you're like, oh yeah, I got to use repeat here. I got to use 17 different maps. and it just works so naturally.
Mm.
The combination of these kind of like combinators like width and rank polymorphism is a match made in heaven, or made back in the 90s by Ken Iverson and friends.
Okay, so then, but here's the thing. I need the pipeable zip transform.
Yeah. Well, that you get that with you get this is why I don't think there's been any feature I've been more excited for. I'm more excited for the pizza operator than I was for C++ 20 and 23 ranges, because
yeah,
I have that stuff now. It's amazing, but like the pizza operator is what unlocks like full linear pipeable programming like this. If we are not able to pipe with half of the algorithms that we have because of variadic overloads and where we have to put those arguments, it's like we got halfway there and then we stopped. I wouldn't go.
I mean, there's no reason that I couldn't do a placeholder syntax.
I mean, we gotta get the committee to agree, but
No. I mean, just in the library, there's no reason I couldn't, make this. Like the way that this thing actually works under the hood is that it has a placeholder thing under the hood.
I mean, my template metaprogramming foo is nowhere near good enough to understand how you could possibly do this in a library. But if you say it's possible, I believe you.
I mean, it's very simple. Hang on.
I mean, I guarantee that it's not that simple, but
it's not that simple. But
as soon as the metaprogramming comes up in C++, we lost a certain percentage of the.
I mean, I already have a thing in the library called unbound, which I have to use in the back end to when I it just makes it easier on the implementation side. So there's no reason you couldn't have this syntax with some placeholder name like this. But I still think I want the so I think that I want the bound transform to look like that. So my reduce, for some reason, doesn't take an initial value. Is that important to take an initial value?
No, just two different flavors of the same thing. I mean, we have both of those. I mean, they're technically folds in C++ 23, but
yeah, should I call this fold?
If it's going to be parallel, it is going to need an initial value.
That's a good point. Does this thing just assume the identity? Probably does.
This is some code you're looking at on another screen. Yeah.
Fine, you can look at my code too. I mean, it's not going to help you much.
The parallelizability is.
Yeah. Okay. Yeah. Look right here. It's it default constructs the result type. Yeah. Probably shouldn't do that.
Probably shouldn't.
Does that need to potentially be a asynchronous input?
I don't think it needs to be asynchronous. It just needs to be an input.
So only the sequences need to be asynchronous inputs?
Yeah, this is I consider the initial value on a reduction algorithm similar to like the binary operation on the transform algorithm. It's just a argument that's customizing the behavior of your operation at the end of the day.
Okay. All right, sorry, say that again.
Basically, the answer to your question is yes, it's only the sequences. Like The longer answer is that I consider an initial value on a reduction algorithm the same as like a binary operation on a reduction algorithm or a binary operation on a two-range transform. It is merely a knob that is customizing the behavior of your operation, your reduction or your transformation. It's not at the same level as like the sequence that is ultimately the data that's being like the operations being performed on at the end of the day.
Yeah. So this is the original set of things that I had. This one we don't need anymore. This one. No, wait. That one we still want. We don't want this one. Well, there's the other question is whether it's I just don't think we want that one. Is it important for you to be able to pipe in something that uses a different range? I'm going to go with yes. So then what does transform look like? Actually, for lack of a better way of expressing this. So is this zip view puts the function first and then the ranges. What should we do? I mean, we could also do this, and then we could have the pipeable version have a different syntax, but that might be confusing. Are you following me?
I got a text and I stopped paying attention for a couple minutes.
Well, that wasn't smart.
What do you? Okay, we got different versions of transforms with different. I mean, you can't do what is on line 65. Your variadic argument has to be at the end. No?
Sure I can. It'll be a variadic pack. I'm just gonna put a constraint in there that the last thing in the pack has to be a be a function, not a range. I mean, what else? Sir, I am working with the tools that have been provided to me by the wise and benevolent
made fun of,
C++ committee. Like, what else am I supposed to do? It needs to be variadic, right?
I mean, so what are you trying to accomplish here?
I'm trying to design an algorithm library. But I need to have a transform that can take multiple things.
I mean, they all take multiple things.
I need a transform that is variadic in the number of input sequences it takes.
Well, currently, all three of those seem to have a variadic number of ranges, no?
Yes, but I'm saying, are we okay with that?
I mean, why do we need all three different flavors of this stuff?
We don't. It's really just this versus this one. And then the last one is just the pipeable version versus the non-pipeable version.
I mean, I understand why this stuff is messed up like this, but like pizza solves this. I mean, we already have this problem with like our zip.
Right, but I don't have that yet. I don't have that yet. I need to write.
As chair of the library evolution working group, you should use your influence and power on the committee to make JF.
I'm trying to write code that I would like to put into the hands of people, like sooner rather than later. No.
I mean, just do your library placeholder thing then. No, wasn't I don't even really like this is.
I mean, yeah, that's the other option. I could do the library placeholder thing if we think that's clearer.
Yeah.
What do we think? Do we
Let's
think
just
that
if we're gonna get pizza in 26, let's just until then hack our own solution together, and by we I mean you.
I mean, I could also let you do it either way. Like you could have the library play. Like I could support the placeholder, or
I just think it's so brutal that like look at line 65. We're splitting our ranges by our function that we're transforming. It's just a mess. Because like
what do you mean?
Because of the limitations, like we're splitting. So we've got our first range, or like sender. Then we've got our ranges. Like those two things.
No. In this case, the sender is just a signal. The sender here is required to send you void.
That.
And the reason for this is just because there's some cases where you just want to do workflow management. I think the requirement has to be that you either send all of them or you send none of them. And so if you're sending ranges, which is the second case here, then they're all going to be sent. And it's going to be a very odd number of things get sent to you. Now, this is going to be a weird transform, though, because it's going to... Well, is it? I guess the question is whether it's going to be an in-place transform. I think it's going to be an in-place transform. How do we feel about that? That this is going to modify the first range.
I mean, I feel pretty terrible about it.
I mean, what else do you want me to do?
Why does this stuff need to be in place? I guess it's too expensive to allocate new memory. I mean,
you want me to allocate new storage? And
I mean, if it's doesn't destroy your perf, then I always prefer like a more functional.
Right, but but people are going to also need the in-place version.
Yeah, that sucks.
Maybe we should just call this for each. It's less confusing.
I mean, we had a whole
what is for each?
We had a whole podcast episode arguing whether something was supposed to be called for each or transform.
Well, no, because it can't be. I'm getting myself mixed up. For each is the wrong name.
Yeah, for each is the side effect one where you just do something every iteration. This is still a transform. That was the thing, is that we ended up coming to the agreement that many of the algorithms, they have the underscore copy.
Yeah.
But some algorithms technically have implicitly that underscore copy behavior baked into them, such as transform. Transform is really transform copy because you have to. Okay,
great. So then transform copy can be the thing that allocates, and then this one's going to be transform.
No. Transform copy is actually the correct name for our transform algorithm, is my point I was making. Because there are certain algorithms that by default do things in place, like sort. And so really there's a version of transform that we should have had a transform that is equivalent to sort, and then we should have had a transform copy that has the semantics of our current transform.
Right.
We don't live in that world.
Right now I'm interested in the transform that's equivalent to sort.
So yeah, we then now have to call that, unless if this is a new library and stuff's not going in the standard, you call that in the standard library though. If it's a new library, sure, just call this transform, and then if you want the one that goes to a different sequence and you have to take care of whether it's already allocated or needs to be allocated, call that one transform copy.
Yes.
Yeah. Look at this. What episode was that? I won. 2 years later. Episode 36, recorded on 2021, July 30th.
What are the
You never agreed with me that or maybe you did actually. We just
I
disagreed.
think I did.
But at the end of it, you did agree that we should have those in place or copy prefixes be consistent, which they are not.
Okay, so are there any other interesting shapes that there's the algorithms that that are there any other interesting shapes?
I am reading the chat. Lambda's saying, do they read the chat?
You remember that chart you made many moons ago? You made one of your talks about algorithms. You had that big table.
Yes, you can find that on my GitHub.
Where?
Go to github.com/code report.
Or no code report.
No underscore. GitHub does not allow underscores in usernames. And go to algorithms, top repository, right there, yeah. Then go to cheat sheet. And go to this. Although,
okay,
this one is not what I want. This is just the state of
right.
affairs.
I want to know what you want.
Okay, I actually have. So go back now. Go hit back a couple times. One more time.
Oh, but let me keep that around just because it's useful. Yeah, where do I go?
Go to the content repo now, the one right next to it, to the right of it. And scroll down till you see Lightning Talks. And click on the STL algorithm cheat sheet one. Yeah. And this is a 15-minute or a 7-minute. So click to click to the 80% mark. We don't need to watch this whole thing. We just need to go find the ideal chart. And pause this. So this is the ideal one. So you can see adjacent difference has been renamed to adjacent transform. Actually, skip ahead a couple. This is not. I haven't made all the adjustments yet. Yeah. So now you can see partial sum's been renamed to scan. Yeah, this is my ideal. What I want. No default binary operations. Renamed algorithms.
Why is there not inclusive and inclusive scan?
Because I don't, in my ideal world, yeah, I think exclusive scan is broken, and I mean maybe there's two different variations, but I just it irritates me the fact that because exclusive scan drops inclusive scan is your scan, exclusive scan is your pre-scan, and by definition, in my opinion, pre-scans are supposed to have n+1 elements, but exclusive scan does not. It deletes the last element, and so you end up with n. So I think exclusive scan is broken. But yes, potentially you should have scan, and if you want to have an exclusive scan, underneath scan, put pre-scan, and that's what I would call them. I'd call them scan and pre-scan. Scan gives you back n elements if your sequence is n elements long, and pre-scan will give you back n+1. And if you want that variation that is like exclusive scan and deletes the last element so you end up with n, you can just ignore that. Or if you're using ranges, you can use a take n on your sequence of n+1 elements. But if you want a little rubric to go by, this is what ideally, and that's the other thing too. Underscore.
Why do the adjacent ones? Why are they not index arity agnostic?
I don't understand what you mean by that.
Why they take two? Why not
a variadic amount?
Yeah.
That is fine. I mean, that's exactly what the ranges versions do now, right? So sure,
I don't know.
anywhere it says 2, replace that with a 2/n, where
Yeah.
you can specify. In fact, just replace it with n and pass that argument as a template argument if you want.
Yeah.
Fine with me.
What's the difference between the ones that say 1/2 and the ones that say
So 1 slash
that
one
those are
slash 2 means that there
1
are,
plus?
and that's the thing is, so which algorithm? So actually,
Why is
there's
wait,
two questions here. But do you know the algorithm in Thrust, NVIDIA's parallel algorithm library, that only takes a single range? It does not have the 2 range overload. And you'll be shocked. I think, like, I always forget this is the case until I try to do something with this algorithm in Thrust, and I'm like, what? This one doesn't have a range overload, a 2 range overload, and then you need to go and whip out the zip iterators, which are
we've
just.
talked about this before. I don't remember which one it is.
You want to take a wild guess? Anyone in the chat? Anyone in the chat know?
Tabulate? I don't know.
I'll restate the question. So there's an algorithm in the Thrust library, has most of the same algorithms in the standard library, and there is one in C++17 that has a 2 range overload, but the Thrust equivalent, which is the library that the C++17 parallel algorithms were based on, the Thrust version only has a 1 range overload, not a 2 range overload. And it's quite shocking because, in my opinion, it's one of the most important algorithms, not just in Thrust or C++, but of all time. And Dunya says, "Don't
It's
look
not
at me."
transform. Well, I don't think reduce has a. I don't know. What is it?
It's transform reduce.
Oh, oh yeah, that's right. We've talked about this before because I was the one who wrote that paper, and it was an addition on top of uh, the parallel algorithms, and by that time the
And
person who'd been working on Thrust was no longer
pause
working on it.
pause here too. So scroll or zoom in so that we can see lines 38 to 44 a bit more.
Yeah.
Maybe a little bit more because it's still a bit small. Scroll down here. So it's brutal because so there's only 1 range, meaning that instead of having 2, so in standard C++17, you've got 2 overloads. You've got the 1 range ones and the 2 range ones. Almost always I find myself using the 2 range ones. So instead of a unary operation and a binary operation, you have 2 binary operations. But what's even like more confusing is that we switched the parameter order. So here, the initial output is in between your unary and binary operation, whereas in the standard C++17 versions, it goes 1 sequence or 2 sequences, then initial value, and then binary operation, and note that
we fixed that in we got it right in the standard version, right?
I mean, what's right? The point is that they're incredibly different. It's like,
well, but it's not right to have the init in the middle.
It's definitely not right to have the nit in the middle. I agree. We got that right. Whether or not the binary operations, the 2 binary operations are in the correct order because they are technically flipped. The one that you do first in the transform is last, and the one that you do last in the reduction is first.
So I'm not going to add the transform reduce and transform scan versions to my library because if you want to do that, you should just use the views, like the transform view. And actually, that makes me think the fact that I'm going to want to let people write. No, not there. I want no transform reduce. I just want people to write reduce, like send reduce views. Wait, what do I want people to write? That's interesting. Maybe I do want them. No. Okay, so wherever if I've got just some range, I want you to do views, transform the range, and then pipe it into your reduction. So because of that, I want a different name for transform because this thing's going to be in place and it's going to confuse people because you're going to use views transform when you do something like the reduction. This is again another argument for why the placeholder syntax would be nice. Yeah. That's like a lot of effort for me to make that work, though.
I mean, does this just views : transform pipe to reduce? Is it
this is single pass.
This is the equivalent of like a transform reduce in the way that these are implemented and like fused together?
Yes. It's not just equivalent. It's all right, people. This is great. I can show people code. I love this. We're doing the podcast like this anymore. Forget the podcast. It's a live stream.
I'm gonna go get a protein bar while you load up whatever code you need to get here.
That's not even gonna take that long. Oh wait, Tito. Is it engineer? No, because we were just there. Oh no, actually it is. You back? This is literally how Thrust implements it.
All right, while you start, I don't want the...
I'm already done. I'm there.
You're
it's
done?
like 2 lines of code.
I'm just saying, I'm muting myself while I eat this so that people don't hear the ASMR of my protein bar.
I don't have anything else to say. Like, there it is. Boom, done. That's literally how we implement it. Like, there's no magic. There's nothing special that we do for reduce. It's just 2 transform iterators that we feed in, or for transform reduce. We don't do anything special. We just feed 2 transform iterators into reduce.
Here's the thing, though. Does the transform that you showed on the previous slide, the views transform, that's morally equivalent to transform iterators all the time, even if it's not followed by a reduction? What if you just want to transform?
What do you mean?
Like, I completely understand that the implementation of transform reduce is just reduce with transform iterators, aka fancy iterators, passed in. Makes complete sense. But because you have transform reduce as a single entity, you can guarantee that like the transform is just an iterator, aka the application of a unary operation before you pass it to reduce. Like, can you guarantee that with this spelling that you have views transform, which is a separate entity to reduce? So like, and with a pipe operator in between it. So somehow the pipe operator in the library needs to know that, like, because these things are adjacent to each other, transform can just be iterators. And I just like, it's not clear to me that like in a naive implementation.
Whoa. You're way off in the weeds. In this code right here, reduce is a parallel algorithm that takes ranges.
Mm-hmm.
This is a range. It's happy.
Oh, and views is
lazy. Like what?
And views is lazy is what you're saying.
Yes, let's literally look at the code. This is the code. This is the code. It takes a range here. It goes and gets itself a CUDA string. It asks the range how big it is. It gets the beginning of the range. It assumes here that it's a random access range, I guess. And then it calls cub_reduce with the range. Cub_reduce, of course. Oh, wait, what?
We're looking at launch. Where was launch? What does that get invoked by?
You really don't want the answer to that question.
I mean, I don't know what I'm looking at then. If I didn't see a launch,
this is the implementation of the reduce adapter.
The reduce.
It gets called when set value is called on the reduce adapter. You don't want to know how that worked.
It has to do with the pipe overload, though, correct?
Yes.
It's there in the background.
The pipe overloads get bound Like, this is the pipeable thing. This is the thing that gets called in the background. That's all that matters. Right, where is launch? Where are we? There it is. And it just takes a range. So whatever the input range is, that's the input range. Now for sort, it's a little bit trickier because I'm pretty sure that cub sort just demands that you give it a pointers, but I'll deal with that when I get there. So anyways, I think that this transform, that this is a bad name now because you're going to be doing this views transform stuff. So what's a better name for an in-place transform?
Transform in place.
I don't want the word transform anywhere in there, actually.
Map in place. The name that every other language except for C++ calls it.
What is there anything else? Are there any other languages to call it anything different? Because we can't use map, unfortunately.
I mean, why don't you like transform?
Hang on, don't you usually have, I don't like transform because it's going to be too confusing. I'm going to be telling people to because of this, because like because this is going to be a thing that you're going to tell I'm going to tell people to do, and this one is lazy, not in place. I know that one, yeah. And this one is in place in parallel. That's confusing. Let's just pick a different name. So not map. Come on, don't you like somewhere you have a table of what every other language calls these things?
Yeah, I'm pretty sure if we bring it up, I mean,
I'll bring it up.
I'm not sure if I have it on Twitter. I can bring it up on. It's on my other computer though.
Just like tell me, it's somewhere. It's on the internet, right?
Yeah, probably code report, Google Map. But I'm almost positive every language calls it map.
We're gonna find the one language that calls it something different. Oh. All right.
I found mapped my tweet with map 2.
Are you looking at what I'm doing?
Here, I'll boot it up on my other computer and then send
How
you
about chart?
a screenshot.
I don't hate chart.
PowerShell. We need to go to closure, CLJS, watch. This is going to build for a second. I mean, I'm almost positive. I think it's map all the way down. I mean, it's implicit.
Hang on. Help me out here. You see what I have? This is going to make you jealous.
Maybe. Actually, so there is here. I won't ruin the surprise for folks.
This is my hard copy of Elements of Programming, a gift from my mentor. I've also got structure and interpretation of computer programs up there.
Actually, you know what? I'll tweet it. Go to my Twitter. I'm tweeting it right now, so you can bring it up. Google translate for map / C++ transform.
Sean's tweet. Oh, I forgot to tweet all the things from Sean from last night. Sean gave a great talk last night.
Oh, at the New York C++ meetup?
Yeah. Oh shit.
Hey, don't swear on my
He's looking.
stream. Don't swear on my stream, buddy. This is PG-13.
I can tell. I can tell just from the thing that he tweeted. It's our code. Hang on, let me reshare my.
Right. Here is the.
I just see Sean tweet this, and I look at the code, and that's code in this code base.
Well, all right. Go to my
Cool.
Twitter now. I just tweeted out what you're looking for. There is one other name that is not map and it's not transform.
Okay, great.
I don't like it though.
Where are you?
Oh yeah, CPP cast. Look at that. They beat us to getting Richard Smith on. Pretty disappointing. Scroll down. There you go.
Each?
Yeah.
I love it. I'm sold.
I love it.
I'm calling it each.
Dunya says, how about map or apply? We already have a apply.
We already have apply. We already have map.
Yeah.
It's each. Boom. Done.
Which comes from either J, APL, or Q. So look at that. Array languages. We stole iota from them, and we stole each from them too.
Okay. So then what other things do I need here that I don't have? Sort. Oh, wait. Are there any of these that are interesting?
Also, for everyone that's watching this, I mean, I'm going to rebrand this live stream as Conor and Bryce just chat about random things. The combinatory logic in C++ will happen at some point. But this has become something completely different than what I intended.
You want scan, you want a JSON scan. Find if. This is just Conor helps Bryce do his job.
You know what? And so it's important, the underscore if, because adjacent find is renamed in my table to adjacent find if. Do you know why that is? Does anyone in the chat know why that is? Because this is once again another place in C++ where we have these suffixes and prefixes that we're not consistent with. The first one that we just chatted about was underscore copy. Technically, it should be, our transform should be named transform copy, and transform should be for an in-place transform. The thing about underscore if is underscore if every algorithm, I think that has an underscore if basically takes a unary predicate, or does it short circuit? One of the two. But the point is that adjacent find takes a unary predicate and short circuits, but they just call it adjacent find, whereas the find if equivalent has an underscore if. I'm trying to think of the other ones though.
Wait, I'm confused.
So I think underscore if, are they for the short circuiting? I can't remember. It's either one of two things. It short circuits or it takes a unary predicate. But the problem is that there's also
find?
So find takes a value. Oh no, that is it.
Yeah.
Find takes a value and find if takes a predicate.
Right.
Count takes a value, count if takes a predicate. Adjacent find, following that pattern, you would expect takes a value, but it does not.
But it
takes a predicate, so it should be called adjacent find if. I think the reason I was pausing on my certainty around that was that there's algorithms like copy if, and I think there's a couple others that don't actually follow that. It's those algorithms are doing some custom thing based on a predicate as well. But the point is if you are not taking a value and you're taking a predicate, you should probably have an underscore if.
There's stuff missing from this chart. Phil isn't on here.
Do you want to explain to the viewers what this is?
This is a chart of what algorithms are implemented in terms of... Oh, no, it is. It's right there. What algorithms are implemented in terms of other algorithms in Thrust. But Phil should be attached to... I don't know, but this is Hang on a second. I don't believe this. That's wrong. I don't believe it. It's implemented in terms of generate. So yeah, this needs to be updated. What's that code? Oh, that's. Let's make a note so I don't forget that. Update parallel algorithms dependency. That is, if I can ever find the dot source file for this, which good Lord knows where it is. That file's from is old. So let's see, which other ones here do we care about? Oh, there's the copyif family. That's a whole important family of them that we haven't talked about. It's actually like one of the biggest families, right?
Mm-hmm.
Interesting. Okay, cool. So copy, and then I should have copyif. I can ignore the I guess there's unique too. If I'm gonna have sort, I may as well have unique. So let me go back to your table. So are any of these ones that I listed more complex?
Note that this table is completely incomplete. It's missing a whole third category of algorithms.
Which is?
The splits. The ones that I mentioned when we were talking with Zach. So these are all reductions or maps, but the splits like views split, views chunk by, views chunk, views slide, views adjacent, those are all not
But
captured.
I don't need the.
You don't need those? Perfect. Well, if you don't need them, you don't need them. But
well, but those are just compositions of other things, right?
No, definitely not. None of these
Why
algorithms
not?
on this screen result in like a range of ranges or a sequence of sequences. These are all either like sequence to sequence or sequence to single value. The third category of splits are sequences to sequences of sequences, or ranges to range of ranges.
Yeah, but I'm pretty sure that you would just implement those with like views on transform, right?
I don't think it's as easy as that. Like that's why I guess at first when I was looking at the transform piped to reduce and I wasn't convinced that it was the modal equivalent of a transform reduce, aka transform iterators with a reduction, is because I can think of a more complicated example where instead of a transform before that reduction, you have a bunch of split-like algorithms that are going to necessitate iterating over some overlapping data. And it's not clear to me at that point that like you can just build up a lazy composition of these things and then pipe that to a parallel reduction and you're going to be good to go. I mean,
Wait, isn't it?
maybe you can,
Don't.
but it's not clear to me that that's trivial or easy.
There's also like join and group by, right?
I mean, join is a reduction technically, so it's not shown
Right.
here.
So we can build join on top of. Yeah.
And group by got renamed to chunk by, but yes, that does exist.
But you believe that? Do you believe that the splits are fundamental?
Yes, definitely. In fact, if you bring up Google delayed block parallel sequences, it's the name of a paper.
Wait, I would say by fundamental, you think that it's fundamental that it has to be that we need to have you can't implement it in terms of a different parallel algorithm.
I don't think so. I mean, I think some of these map to the segmented reductions when you have a composition of things. So like, for instance, if you have a chunk by followed by a transform where inside the transform you're performing a reduction, that is essentially a segmented reduction. But that was the composition of like 3 specific things in order to be able to map to that. So like there are certain things that you could do currently with thrust and the segmented algorithms that would be the moral equivalent of like splits followed by some other algorithms, but it's a very specific mapping from like A plus B plus C equals this segmented reduction. There's not like a generic set of things that you can just compose together and do whatever you want.
Okay.
Google the paper. Delayed block
What?
or delayed, block parallel sequences. This is my favorite, not my favorite paper of all time. Definitely favorite paper I've read in the last 3 months. Maybe last year. Maybe last 2 years.
This one?
Correct, yeah. The talk also is great for those that need more content to consume. So this is out of Carnegie Mellon. If you scroll down to basically a certain point, yeah, right there. So note that, zoom in on that box of operations. I think what's interesting about this list of things is that all of them basically fall into maps and reductions. If you go and take a look at ParlayLib, which is the C++ library that backs this stuff, they do actually have algorithms like group by, but I can't remember when I looked at the implementation if they actually were implemented. But the point about this box that I just wanted to make is that it's like maps and reductions are the easy things to build up when you're building these kinds of like parallel flavored libraries. This paper talks about like 2 different types of fusion, index fusion and stream fusion. And these types of algorithms basically very nicely lend themselves to this type of fusion. But these split algorithms, I think part of the reason you don't see them in this list is like they're much more, it's not impossible. I don't think it's impossible. It's just they're much more difficult to think about because you end up with like irregular shapes of lists of lists. And if you don't have like a regular rank 2 array where every sublist is the same length, like what do you do with that on accelerated hardware like a GPU where, each thread is supposed to, or, each warp block, whatever level you're at, is typically going to get like the same chunk of stuff. It's much more difficult to reason about parallelizing that kind of stuff. And that's why I think it's like a fundamental. There's other reasons why I think it's fundamental, but yeah, maps.
But we don't have these in any of our libraries today, right?
Nope. It's one of the things. That's why when we were talking to Zach and he was like, "Why do you like array languages so much?" Is after operating in like C++ for so long, all of the operations are like reductions and maps. We not until C++ 20 did we ever have an algorithm in the category of splits until C++ 20 stood : views : split. And then in C++ 23, we get a lot more. And it's very limiting to be in a world where all you have is reductions and maps. And then you enter Haskell or you enter APL, and there's a whole category. Like there's chunk by, there's slide. Like the same way that you can think of, min element, max element, min max element, sum product. These are all specializations of reduce. The exact same thing exists in this like split category of algorithms. There's the most generic chunk by, I think that's one of the most ones, which takes a binary operation, but there's chunk by key, there's slide, and all of these can sort of be specified in terms of one or another. And in C++ Topia, it is a very neglected pillar of algorithms, in my opinion, and fundamental.
Mm-hmm.
Yes, Mike in the chat said they're called unfolds, which is correct. There's a paper called Beautiful Folds, and I believe it talks about both folds and unfolds. I think it's by Graham Hutton. Could be wrong about that. And I think in category theory, I mentioned this in the podcast, that it's they're referred to anamorphisms, but I actually don't like the technical definition of an anamorphism is a function that iteratively invokes a function over and over again on the previous result. And that doesn't necessarily result in a sequence that has a sort of like increased rank compared to the prior sequence. Yeah. So, I mean, I used to refer to these as anamorphisms, but I don't think technically in my like mental model, that's what these things are. Like you can think of it like when you're in Python and you have a list and it's bracket, elements separated by commas. splits are things that go from that to now we've got 2 sets of brackets, one for the outer lists and then brackets for each of the inner lists. And I think for NVIDIA, probably the easiest thing is to try and live in a space where most of our operations, we kind of force people into this regular space where we require people to deal with like multi-dimensional arrays, where the limitation is each sublist has to be the same length. And the programming language J actually does a lot of interesting things where there are certain operations that inherently lead you to like a triangle-shaped table where the length of each sublist grows by 1. But instead of doing that, they'll do something like, pad each list with a default value so that you necessitate ending up with a matrix, a rank 2 array, where every row is the exact same length, which like a lot of times is not what you want, but at least it leads to like regular shaped things. And so that like it's when you have a matrix, it's much, much easier to parallelize something over a matrix than it is to a regularly or like jagged shaped list of lists. Which is why J is very interesting for that. Like there's a lot of operations in J that I think the motivation for it was exactly that.
Okay. We should talk more about this though. Not today because I think I've already bit off more than I can chew.
It's a good 2-hour stream.
Yeah.
What should we call this?
Beats me.
Chat.
We do have this segmented reduction in Cub.
Yeah. If you want to see something here, I'll see if I can find it actually. If you go to MatX, I'll see if I can just find it for you. Send it to you on Twitter.
There's all the by key algorithms too. Well, the most productive thing I got out of today was each. That's great. I love it.
Well, I don't think this is exactly what I want. Here, how do I'll send this to you via the chat. I thought he had it in the reduce.
Oh, are we recording tomorrow?
No, we still got a couple more weeks of.
Yeah, but keep in mind, I'm going to be gone like all of June, and I do mean
I'm going to be gone
literally
all of June too. But I got, you know what I bought? I bought a mic, so now we can take our podcasting, interviewing skills on the road.
Yeah, when are we? Wait, when are we going to? Was it Armenia, Slovenia? When are we supposed to go to Slovenia? You got to give me dates.
Where? Just bring up a calendar. I guess I can do it on another. Although now we're on a live stream, just like talking about our.
What? So and.
All right, I'm going to Poland. I'll be in Poland, I think, at the end of May, a couple days before the conference that's on the 5th and 6th. I actually submitted to speak at C++ Italy, which is in Rome, on June 10th.
Yeah, I may speak at that. Well, because I'm going to be on the way to the committee meeting.
Yeah, we should do it. We'll meet up in Italy. You'll go to the committee meeting.
It's a little bit complicated for me to get to Italy, but I can try. So I am.
Committee meeting's the 12th to the 16th, right?
Yeah, I am I leave here May 31st. Hang on. I gotta.
Can we come along? Yeah, sure. If you guys want to meet up in
Let's see. I get to London. I get
really
to
showing
Tel
your
Aviv on the
flights
2nd.
details.
I get to Tel Aviv on the 2nd, and then I leave on the 8th, and I haven't booked anything yet, giving me the option to go to Italy. I guess I could go to Italy, then Sofia. That's probably fine. What day? Yeah, okay, all right. I'll think about that. Then I'm gonna have 2 flights, so there probably isn't a direct flight to Varna from Rome. I'll look into it. I'm very backlogged on
Bring up
figuring
a
out
map
travel.
of Europe.
When are you going to be in Slovenia?
So I think, well, if we're going to try and time it together, I'm not going to be at the committee meeting because I don't go to those anymore. And it's going to be too tricky for me to get, like, if I'm going to Italy, I mean, pending that I get my talk accepted at C++ Italy. So, like, if I get rejected, technically we could go to Slovenia right before the committee meeting. Are you going to core CPP as well? You are.
Yes.
So like I could go from Poland to Slovenia. You could go from Israel to Slovenia.
Yes.
We could do that for like 3 or 4 days. You could go to the
as long
meeting.
as long as we're not trying to do it afterwards, because the problem with afterwards is I'm going to be in Vienna right after the committee meeting on my way back, and then I get back on the 20th, and then I leave again on the 25th.
You said, you see this now. We've only got 23 viewers because people don't care about what we're talking about now. But you lied to me, Bryce. You said you were going to be in Europe for most of June. You lied to me. You're going back to New York, and then you're coming
for 5 days. For 5 days.
Which is when we could have been. So if I do get accepted to C++ Italy, it's not really going to make a lot of sense for me to go from Poland to Slovenia. Actually, it could be. We could just do it for a day.
But you're gonna. When is your conference thing?
Which one?
The thing that I'm leaving on the 20th, on June 20th.
I'm like, so C++. I mean,
well, hang on.
Have you booked your C++?
My only constraint on the flight back is.
Man, I haven't even booked anything. Actually, that's not true. I have my flights to Poland.
My only constraint is that on June 20th, I need to be in London to fly home.
Yeah, so worst case, you duck out on Saturday, come to Slovenia. We've got 2 days there. Or in between, you go from...
So my plan... Hang on.
It'll work out. Worst case, too. I mean, I'm staying in Europe for that week. You can just show up to C++ on C a couple days earlier. Fly into Slovenia, pop over to London.
No. I gotta fly home and then back.
Well, you can't come early? Can't come early to C++ on C?
I don't. One, I'd have to pay for hotels for like 5 days, and 2, like I got I got to go back.
Mr. First Class can't afford a couple of whole hotel nights.
That is true. So I'm planning on leaving Varna on the 17th, and I was gonna go to Vienna, but I could really go anywhere.
Yeah, let's do that then. Post committee meeting, we'll meet up in Slovenia. Ljubljana, here we come.
Actually, hang on. Let's look at a map. Let's look at a map of Europe.
I told you to bring a map up. Slovenia is in between. I mean, it's going to kind of mess stuff up for me a little bit, but.
All right.
What is wrong with your internet,
hey, perfect. Man? You know what? Dude, this is perfect because I'm flying into Vienna, which is, come on, Google Maps.
Hey, what is wrong with your internet? You got to upgrade your internet, my guy.
So I'm flying into Vienna, which is pretty near Slovenia, so.
Yeah, perfect. Just hop on a train.
Don't
even change your flights.
Yeah. Woo.
And I've got here. Look, I'll go get it.
Wait. No, here's the real question. Okay, so let's see. Where are we going to in Slovenia? What's the capital of Slovenia? Somebody put it in the chat. I don't know what the capital of Slovenia is. There it is.
What do you mean? It's Ljubljana. We talked about, this guy. We had an episode that was literally titled Ljubljana, Here We Come, because we made
You
a.
know, I don't watch the podcast.
First of all, you don't watch the podcast; you listen to it. Second of all, you should at least, you retweet it and stuff. Look at this though, Bryce. Or you can't see it because you're not watching the YouTube live stream. This is a professional grade interview, omnidirectional microphone. Boom.
Where are you going to be on the 17th?
I don't know. I got to go to Switzerland for a while. But I could go to Switzerland afterwards. I got to figure out somewhere to go. So. Why does it matter?
I'm wondering if we meet up in.
Or you want me to come to Vienna so we can train and we can document the journey together?
Maybe. Okay, here's what I think I need. You need to send me all of your current planning and your current what conferences you're going to be at, when you're going to be there, what you have booked right now, and then I'll try to figure out what makes the most sense.
I literally have one flight booked to Poland a couple days.
Yeah, but just send me the itinerary of stuff you want to do, and then I will figure. I can, this is like my passion. I'll spend some time, maybe this weekend, probably next weekend, trying to figure out like the best options.
Look at this, yeah. Balian in the chat.
Wait,
Bryce's travel agency.
When do you fly to
Poland?
Europe?
Like a week earlier. It's actually not on my calendar. I can't remember. It's like the 29th of May or the 30th of May. So I've got like a week in Poland before I have to be in Krakow.
Wait, the 30th of May? Have you booked that flight yet?
It's booked, yes.
Oh. Can you get your money back?
I don't think so. I think I booked a non-refundable thing. Why? When are you flying into Poland? Wait, are you flying into Poland?
No, but I'm flying through Toronto.
We already talked about this. You're going to be an international and I can't come visit you.
No, but I'm leaving on the 31st. You're leaving on the 30th, you said.
Something like that, yeah.
Okay. Well, let's... Oh, I don't have...
Let me check.
All right, well, let's just see if there's... Let's see if there's still seats in my flight.
Anyways, we should really end this live stream because...
We probably should end this live stream. Which one am I on?
Here, wait. Let me find... All right, folks. Thanks for tuning in to this completely... I mean, this is on topic, not for this YouTube channel, but for whenever Bryce and I get together, we talk about completely random things. Thanks for tuning in. I do not know when I'll actually do the Combinatory Logic and C++ live stream. I mean, I feel like I was going to do it. Maybe if I find time...
I mean, Conor.
I got to end this live stream. I got to end this live stream.
Okay, end the live stream.
Thanks for tuning in, folks. Stay tuned. I only gave 2.5 hours notice on this live stream. When I figure out when I'm actually going to do what I was planning on doing today, I will announce it a few days in advance. But yeah, hope you found whatever this was entertaining. Expect the title and thumbnail of this to change, considering we talked about random stuff. Have a great day. Stream's ending, and we'll see you next time. Say bye, Bryce.
Bye. See, the problem is I just